my name is Tiemen, and I will give a presentation about the Bricsys company and the BricsCAD product family and how we work together with the Open Design Alliance to create our products. So first, a couple of words about the company, Bricsys. Bricsys was founded in 2002, and the main headquarters are located in Ghent, which is in Belgium. And currently, we have our software is available in more than 80 countries worldwide. Bricsys is also part of a larger company called Hexagon, which has a broad portfolio of both hardware and software solutions for the AEC space, for plant, marine, manufacturing, and so on. Bricsys is also one of the founding members of the Open Design Alliance, and since 2 or 3 years, we are also an international member of Building Smart. So Bricsys is the developer of several products. The first product is BricsCAD, which is our core DWG-based CAD platform. It can be used for 2D drafting, 3D modeling, and parametric design, and everything is based, of course, on the DWG platform. We also have an ecosystem of more than 1,500 application developers that have a third-party application running on top of the BricsCAD platform. On top of BricsCAD, we have 2 vertical solutions. The first one is BricsCAD Mechanical, which allows you to create mechanical assemblies and sheet metal models, and to generate 2D mechanical drawing views as well. A second vertical solution is BricsCAD BIM, which is more aimed towards the AEC space. So it's a tool for architects, engineers, contractors, with full support of IFC certified BIM workflow and construction documentation. Of course, throughout our products, we make extensive usage of some of the libraries of the ODA. Of course, the drawing SDK is at the basis of our BricsCAD core platform. If we didn't have access to this drawing SDK, we would have needed a huge team dedicated to just DWG interoperability. We also make use of other SDKs from the Open Design Alliance, like the Civil SDK and the Mechanical SDK. This ensures compatibility with mechanical drawings and civil 3D drawings as well, which is also available in our product. And last but not least, in the BricsCAD BIM product, we also use the BIM SDK, which ensures compatibility with the RFA file format, so Revit files, and it allows our users to open and import Revit families, giving our users access to a huge library of components that can be found online, and they can be used directly in the BricsCAD BIM product. So I'd like to show some of the technologies that we are using in the BricsCAD BIM product. So the BricsCAD BIM product is an application where you can start modeling in 3D. So unlike a typical library of parts approach, we have direct modeling tools that allow you to create any geometry, complex geometry that you want. And you can start adding the BIM data in a later phase. So for example, you can classify your solid geometry, you can add information about materials, compositions, buildings and stories, all of which is of course also supported through IFC export and import. In order to support this, or in order to automate adding the data to the model, we use several technologies of artificial intelligence, and I'd like to show 2 examples. The first one is BIMify, which is an automatic BIM classifier. So it will detect a 3D solid model. In this case, this is just a dumb 3D solid model. It can be imported or it can be created in our software. And after running BIMify, it will automatically detect buildings, stories. It will try to determine the correct IFC classification types, like IFC wall, IFC beam, and so on. And it will also detect structural steel profiles. It does a lot more than this. It can also detect rooms and so on. But basically, the idea is that you can go from a dumb 3D solid model into an intelligent BIM model in just a matter of seconds. A second example is Propagate, which is a technology that can propagate a detailed connection throughout the rest of your model. So we have modeled a detailed connection between a wall and a slab, And this propagate technology will automatically try to find similar places in the model where the same detail can be applied. So again, it allows you to very quickly add BIM information or level of detail in your BIM model. Another example is where we use technology to automatically increase the level of detail of your BIM model is parameterize, which is technology that can automatically create 3D constraints and parameters from a component. So in fact here we will show an example where we use the ODA technology to import RFA files, so Revit family files, and they can be used directly within the BricsCAD BIM model. So we have a collection of Revit families here, which we can access through a components library, and we can directly drag and drop these components in the model, and on the fly they are being converted to BricsCAD BIM components based on DWG. In this case, we have imported the component without any parametric information, so it's just a dumb 3D solid. But in order to fix that, we can quickly use a tool called parameterize that will automatically detect which parameters and constraints are relevant for this component. So after running parameterize, you can already see in the top right that it has detected several constraints and parameters. And if we animate these parameters, you can see the effect of the parameterization of this component. Of course, you are free to add additional constraints or rename the parameters and components as you like. And if the component is as you want it, you can replace it in the BricsCAD BIM model. And now you will have a fully parametric component. So you can change, for example, the width of this door in the BIM model. So these are just a few examples of how we use ODA technology with our own direct modeling technology and AI technology to create a product which has a very intuitive and efficient BIM workflow. If you have any questions, please feel free to ask me or one of my colleagues. We are here today and tomorrow. So thank you for the attention.